Section 6.5, conditions for rhombuses, rectangles, and squares. So we are going to first determine if it's a rhombus or rectangle. Two theorems. I'll make them a little bit bigger here. Theorem 6.16, if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So when we looked at properties of rhombuses, that was one of them. So here, if we already know that those middle angles are right angles, then we know for sure it's a rhombus. And then you can assume that all four sides are the same because, of course, that was what the definition was. So if the diagonals are perpendicular, then it's a rhombus. Assume that all the sides are the same as well. Theorem 6.17. If one diagonal of a parallelogram bisects a pair of opposite angles, then it is a rhombus as well. So all we need is one diagonal, but once it's a rhombus, then both diagonals will actually do that. So, but you only have to look for one with theorem 6.17. Again, if you know that it bisects, then you can assume that all the sides are the same, and that might help you to find some missing parts if needed. Theorem 6.18. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So again, you're going to, if you're forcing it into being a rectangle, then you're going to set those diagonals equal and force them to be equal. Once you know that those are equal, then you can assume that you have right angles, and you can solve for any missing parts there as well. So if you are trying to show that the parallelograms are rhombuses and square, or rhombi and square, these are the theorems that you're going to use. So when it says then it's a rhombus at the end, you're going to actually, show that it's that shape. If it says it is already a rhombus at the beginning, then it's a property. If it says you're going to show that it's a rhombus, then you're going to use these that end with that. So last one, if a parallelogram is both a rectangle and a rhombus, it is automatically a square. Don't write this in your theorems, but you might want to write this in your notes somewhere. That's just kind of a property, so to speak. So when you are showing something, and we're going to have some graphing questions that we have to do, it's going to say, is the figure a rectangle, a rhombus, or a square? You're going to have to show each one. So last time I think there was a student that asked, do we have to show the ones that it's not? You didn't then, but you do now. So those particular things, you can't just look at the picture and show it. You have to draw the picture, and you have to use one of these theorems to actually show it. So they're a little bit more involved than those other ones were when you were just saying, yep, it's a rectangle because it has right angles. There's going to be certain things that you have to show now. So problem number 1, can you conclude that the parallelogram is a rhombus, a rectangle, or a square? And then explain. So in figure A, notice that there's some diagonals in there. So with the theorems that we just wrote down, this one has to do with diagonals. If the diagonals are equal, then it's a rectangle. Okay, so let's look at that. Well, we only have one diagonal in there, so it's probably not the ones that are equal, otherwise they'd show that. So I'm going to look for the rhombus one. Here it says if the diagonals are perpendicular, well, there wasn't any right angles in there. If one diagonal bisects a pair of opposite angles, that's actually the one that they're looking for. So if one diagonal bisects the angles, and it does, and we know it's bisecting because this one is the same as this one, that one is the same as that one. So we're going to say yes, or not yes, but we're going to say rhombus. Theorem 6.17. Or you can say a diagonal bisects a set of angles, or, bisects the angles. So it only has to be one. On the next one, what do you guys think it is? Rhombus, rectangle, or square? Okay, maybe. Anybody else? So we have some diagonals. We also have some angles in there. So we have right angles in the middle. And what is it when there's right angles in the middle? Rhombus, rectangle, or square? Rhombus. So far we have rhombus. What happens when the diagonals bisect each other? Okay, so let's look at them again. If the diagonals are perpendicular, then it's a rhombus. So we have that for sure. If one diagonal bisects the angles, we don't have that this time. And if the diagonals are congruent, then it's a rectangle. Okay, do we know that the diagonals are congruent? Yep. So then this one is a rectangle for sure, right? And a rhombus. So what you're going to do is you're going to go with each. So we're going to say rectangle. And that one is congruent diagonals. I'm just not going to use the theorem numbers because I don't want to page up again. It's a rhombus because it has right angles. That one's 616. And what happens if it's both a rhombus and a rectangle? It's a square. So you can't just say it's a square. You got to show each one. And all I'm going to say is both rhombus and rectangle. So on the ones that are just one, you only have to show the one. But if it's a square, you have to show every single one because it has to be both. And then you're going to give reasons. And you can give theorem numbers, you can write it in words, whatever you want to do is fine. Okay, so here's a got it question. Can you conclude that it's a rhombus, rectangle, or square and explain? A parallelogram has angle measures 20, 160, 20, 160. So of course you can draw your own picture if you want to. So I'm going to say this is 20, 160, 20, 160. So let's look at a rhombus first. And I'm going to have those handy here so I don't have to page up again. So for a rhombus, we need diagonals or perpendicular. Did it say anything about diagonals here? No. For a rhombus, we also need one diagonal bisects a pair of opposite angles. Do we have that? No, we didn't have any diagonals. All it said was, here's the angles, okay? The next one said diagonals are congruent. Don't have that either. So is it any of these? Rhombus, rectangle, or square? No. So when you're looking at it, you're going to do this. Okay, so no right angles. Not a rectangle. And that's by definition. Here, the only thing you have is that opposite angles are the same, and opposite angles are the same means it's just a parallelogram, right? So we're going to say not a square because it's not a rectangle. To be a square, it has to be a rectangle and a rhombus. And could it be a rhombus? Could be, except we don't know what the side lengths are. To be a rhombus, you either have to have those perpendicular diagonals or all four sides have to be the same. So here, it doesn't show that. So, but you could say, not sure about side lengths. We're going to say not a rhombus because otherwise they would show what they were. Or doesn't have perpendicular diagonals, not a rhombus, you know, whatever. Okay, suppose the diagonals bisect each other. Okay, so that's all they're giving us. So we're going to say diagonals bisect each other. Okay, would it be a rectangle, square, or rhombus then? Or could we specify which one it is? If you go way back to the parallelogram theorems, it says the diagonals bisect each other in a parallelogram. It doesn't necessarily say anything about anything else. We're going to say no. So here, I think it's just a parallelogram because that's what it said way back. If the diagonals bisect each other, it's a parallelogram. So next, most people have the most trouble describing which one it is because you have to be specific. We generally don't have trouble with these, okay? We're using them, we're solving them. Basically, you're going to have to know, do I set the things equal or do they add up to something, okay? And that's kind of what you're asking yourself. So here, they want to force it into being a rhombus, so a diagonal bisects a set of angles. So when it bisects, it cuts it in half. So here, we're just going to set them equal. Show your equations, please, again, as you guys are doing your homework, and then you can solve and skip steps here if you want. 4x, if we subtract 4x from both sides, we get 2x minus 2 equals 8. And then we're going to add 2 to both sides, so we get 2x equals 10, x equals 5. And it just asks for the value of x, so we do not have to plug them back in. If they did, we would plug it back into one of them because both of the angles are going to be the same. So sometimes they ask for that, sometimes they don't. So the diagonal bisects the set of angles. And then there's one last question here. For what value is it a rectangle? So with this one, they're only giving part of the diagonals. In a rectangle, does the diagonal bisect the side? It kind of does. So there's actually two different things you can do here. So when we look at it, if you want to do the whole diagonal, it would be really 2 times 5y plus 3 is going to be equal to 2 times 7y minus 5, right? But if they're both doubled, could we just say 5y plus 3 equals 7y minus 5? Because your 2's are going to divide out anyway. If we divide by 2 right away, it cancels those. So they really are two things that are equal. So now we'll be solving this. 5y plus 3 equals 7y minus 5. It was, if it were anything except for a rectangle, you couldn't do what we just did. You would have to like double them and then set them equal or add them together or whatever. So I'm going to put the y's on the right where they're positive. I'm going to add 5 to both sides, and my y is equal to 4. So for this one again, what's the value of y? We have found it. We are done. Sometimes they'll say, what's the length of the diagonal? And this is where you have to be really careful. If you plug it back into only this part, you would have to actually find it and then double it to get the whole entire length. So that's the only thing that I want you to be careful about with rectangles. You can initially just set these two equal to each other, but when you're finding the whole length, make sure you find it and double it instead if you haven't written that whole length down. And that's all I have.